For this project, all what we need is one LAN cable. So this is RJ45 straight LAN cable, which we need to connect to the Ethernet shield to the home router. Then we need Arduino Uno. We need an Ethernet shield, Arduino Ethernet shield, which has a Visnet W5100 chip on it. We need a USB cable which will connect to the laptop and the Arduino Uno. Then we need an internet router. This could be the home internet router or at the office. That's all right. You can use any internet router. Just make sure you have the one. And the question is how we will going to connect all of them. So if you look at Arduino Uno, it has this male headers, right? On the both of the side, right? So what we can do is we can take this Ethernet shield, and Ethernet shield has a male header wire wrap. So what we can do is we can stack this Ethernet shield on the top of Arduino Uno. And if you look at this, all the sides, you can see it can fit properly, okay? Especially this 6-pin ISP headers. You can see the 6-pin ISP header, okay? All the sides, right? And we have to press this little bit so that they can fit it properly. You can see when I press, now there is no space between the pins, right? And they can stack into one another properly, right? That's very important. Otherwise, you might not able to see your Ethernet shield working. So once you stack Ethernet shield on the top of Arduino Uno, then next step is to power up your Arduino board, and you can take the USB from your laptop and connect to Arduino Uno. So right now, as you can see, the Arduino is powered up. Right, you can see the power LED is glowing here. That means the power, your Arduino has the power. The next step is to connect Ethernet shield with internet, and that can be done by using this LAN cable. So I can connect one end of the LAN cable to Ethernet shield, and other end of the LAN cable, this one, the other end. One end is to Ethernet shield, other end is to internet router. So let me connect to internet router. And as soon as I connect to internet router, you can able to see all the LEDs are blinking except this TX and RX LED, right? I hope you can see them properly. Now the question is, when you connect everything, how can you make sure the connections are properly done? I mean, not just a physical connection, but logical connection. So the first step is to check at the Ethernet hub, right? If I can take this little bit up here, you can see there are two LEDs. I hope you can see this one is a green LED, okay? This one is a orange LED, and you can see one LED is blinking, one LED is blinking, and this green LED is steady, right? If these LEDs are not glowing, this green and orange, that means the connections is not properly done. You have to check the other end of the LAN cable, right? To router or to computer. We are connecting to routers, so just make sure about routers. And you can see this other LEDs, I mean this power LED, link LED, then 100M, full D, and collision LED. Collision is not blinking, of course, but TX or X, they are turned off by default, and they will only turn on and off when transmit and receive happens over Ethernet shield. So this is how you will going to connect your Ethernet shield to your internet router. So the program that we will going to do here in this example is we will going to connect an LED to pin number 8 of an Arduino and Ethernet shield, and then we're going to control this LED connected to Ethernet shield over Webserver. So I will take this LED, this red LED, and I will connect to pin number 8 of the Arduino Ethernet shield and ground. Pin number 8 and ground. So once the setup is done, I hope you can see this. The longer leg of the LED will going to connect to pin number 8. Look at this longer leg of LED going to connect to pin number 8, and shorter leg of the LED will going to connect to the ground. Okay, so the setup is done. Now you just have to, write a code and control this LED using a web server.
What you can see on my screen is a bare minimum code where we have a setup function and the loop function. The way we're going to start writing the code to create an web server using Arduino and Ethernet shell is by using some libraries and writing some code. So the first thing we have to define is we have to include a file that will be about the SPI bus. So we're going to write hash include spi.h. The reason why we add this spi.h header file is because the way we connect Arduino to Ethernet shell is using SPI pins, SPI communication. The second header that we want to add is ethernet.h file. So we'll say hash include ethernet.h. Once we are done with adding these two header files, we have to initialize a pin. That's where we will going to connect an LED. So integer LED is equal to 8 because we will going to connect an LED to pin number 8. Then we have to define a byte variable that will be the array MAC, and this will be an MAC address of an Ethernet shell. Now you have to understand these things. If you have an Ethernet shell which has an MAC address, means when you buy your Ethernet shell and if you have given the MAC address in the piece of paper or maybe in the back side of your Ethernet shell, you can use that MAC address. If you have an Ethernet shell which doesn't have any MAC address or you lost it, then you can write a user defined MAC address. The thing is, you can give a 6 bytes of MAC address. You don't change the format of it, but you can change it as a user defined MAC address, right? Don't change the format, but you can give it. So if you don't have the MAC address, then you can use the one that I used in my code, 0xDE, 0xAD, 0xBE. Make sure these are the hexadecimal numbers and these are the 6 bytes. Right, it should not exceed more than that. That's why I'm keep saying you should not play with its format. You can experiment with the hexadecimal number but not with the format. 0xEF, and let's say 0xED. Let's make this way. So you can see 1, 2, 3, 4, 5 and 6. These are the 6 bytes. Once it is done, we just have to use an Ethernet class from this ethernet.h header file. So we can access the class Ethernet server and we'll make a server which will be listening to port 80. Now you might get a question why I use port 80, right? Because 80 is a standard and very popular TCP port which is often used, so we're going to go with port 80 for the server, right? And then we'll make one string variable and we'll give it a name, read string. That's it. And in the setup function we have to initialize a serial function, serial.begin, and we'll set up the baud rate 9600. Okay, then we have to define a pin mode for an LED that will going to connect to pin number 8 LED, and it will be into the output mode. Then we'll make an Ethernet. We'll initialize a Ethernet shell by saying ethernet.begin, and we will pass a parameter that is the MAC address, right? Then we'll take a server.begin, so this will initialize the server, and then we'll say serial.print. We will throw the text on the serial monitor by saying server is at address, and the address will be serial.println. And what will be the MAC address? IP address that has to be given or maybe assigned by your router to your Ethernet shell. And by printing this Ethernet, sorry for my typo mistake, I'm not very good with that, but we'll say ethernet.local IP, and this will gives us the local IP address assigned to your Ethernet shell by your internet router, and we're going to print this on our serial monitor, and then we will grab it and browse onto the browser to see the web server. right? Our web server will have two buttons to on and off the LED. Okay, once the setup is done, we will come back to the loop function, and in the loop function we'll make a little bit of space, and then we'll say Ethernet. Let's say this time we have to make a client, Ethernet client. Earlier we made Ethernet server, and we'll say Ethernet client is equal to server dot available. We have to check whether the client is available or not. If the client is available, then we have to check while. If means while your client that is connected or not. So we'll say client dot connected. Okay, if it is connected, then we're going to check again with if statement. If your client client dot available, if it's available, then it will return something from it, and whatever something that if it found the Ethernet, if it's found the client, then it will return something, and it will be stored in character variable C, and we're going to say client dot read. So whatever we'll read, we will store into the character variable C, and then we're going to print this into serial dot print, and then we're going to print this onto the serial monitor. If this is done, we go back again here, and here we have to check if, and we're going to say read string. If the read string length is less than 100, then we want to store this read string into the value of C into read string by saying read string plus equals to C, means a read string is equal to read string plus C. So whatever it comes, it will be stored into the read string, and then I will tell you later how it abstract the information that we are sending when we press the button, and that will turn on and off LED. So if this is done, then we go ahead and make another if statement where we check if C is equals to new line, because whenever Ethernet clients, whenever your Arduino Ethernet shell connect to an internet as a client, Ethernet client, and whenever you send an HTTP request from your browser to access the web page on your Ethernet shell, it will whenever every HTTP request finish, then it will send a new line character. So we check every time when the new line character has been received, so it will refresh the web page, right? So we check if something new updates are there or not, right, in order to make sure the right information coming or not. So we check whether the new line character is there or not. If the new line character is there, then we'll say serial dot print, and then we're going to print this read string. We just have to make sure what is coming on a read string. Once it is done, then we'll say client dot print. You can say print ln, and that is absolutely fine. And in the double quote in HTML syntax, you can first say HTTP, because that is what HTTP server that we're going to make 1.1 and 200 OK, which is an HTTP request. This is a pure HTML. If you don't understand for now, just bear with me. So client dot print, and then we have to say connection type. Now we have to define connection type, and we must say it's a text HTML. Okay, once this is done, then we must say client. Oh, I'm really tired with this typo. Print ln, you can have print ln here as well, and then we must say connection to be closed, right? So we'll say connection, and this will be closed, right? And once this is done, we'll say, I just do a little copy and paste, right? I'm not very good at typing. and then we just say nothing here, right? Just to wait for a couple of milliseconds. Once this is done, we'll do copy and paste again, and here we must say HTML here. Okay, we say doc type. This doc type is HTML, and I will use copy paste again. To here we will going to start writing a HTML web page, right, on our web server. So we would have to say client.print, and this will be like HTML tag now, just a normal HTML tag, and then we have to say client.println, and then we have to say head. Okay, and we have to start a head and say head closer, and then we have to give the title to the web page, and title title, and I would keep it rather very simple, web server, right? So that will be closing of the title tag, HTML tag, right? Once this is done, we must take another HTML tag, that will be the body. We're going to make the body of the web page, and then we also have to copy and paste here a little bit. Okay, and this will be rather the body of the web page, and then we have to say style, and style is equal to background color, and I want to keep the background color is a powder blue. That's what I love, powder blue, right? And I would take here, and because I want to make two buttons on my web page, right, I have to write that what exactly I want to do with these two buttons. So I would rather create a HTML tag again and say href reference is equal to, and then rather I have to say here the button one. So I will say button one on. If this button one on will be trigger, then just let me type it first. It's very difficult to do two things together. This is the button tag and button close tag, and the name of the button is LED on, the first button name, and this is closing, right? So this is the first button, LED on, and I would do copy and paste for second button, and second button would be button 2, and this will be off, button 2 off, and the name of the button will be off, right? So let me check whether the syntax is okay. Looks okay for now. That's okay. We just have to give a delay of, let's say, 1 millisecond. It's more than enough. Then we'll say client dot stop, because we have to stop the client. Once we stop the client, then we have to do a real logical step where we check if read string dot index of, it will check whatever there into the read string, because we are storing everything on a read string. Whatever coming from the HTTP web server, that will stored in C first as a character, and then it will be pushed into read string. So whatever, when you press this button, LED on button, it will send this LED on 1. When you press the second button, which is LED off, it will send this button to off. So we have to check when we press the first button, then it will check if it's a button 1 on. If it's a button 1 on, then it will be greater than 0, and then we have to say digital right, and we have to make an LED to become an high, and I can do a little magic of copy and paste, because I'm not very huge fan of typing a long codes, right? So this will be, if second button is pressed, it will check if button 2 off is there into the read string. If it's there, then it will make this LED low to turn off the LED, and then in the end we'll say read string is equal to, we'll make this string empty, so there will be nothing into the read string. Okay, if this is okay, I would remove this ugly space here. Rather, I love code to be better, so I would hit Control A and then Control T to align the code, so auto format the code so it will look a little bit better so as to read. Okay, so I have 5 closing braces, so looks perfect. Okay, and it's a time to check the code, right, and see if it works. So let me go, and upper left corner there is upload button, so let me upload the sketch to my Arduino. It says there is an issue saying output was not declared output, so there is no T, so I forgot to give it T. So let me upload again and see if there is any error. Seems there is no issue for now, so waiting for uploading. In lower left corner you can see it's still uploading. Done uploading. Let me open a serial monitor. So when we open a serial monitor, then our Ethernet client, Ethernet shield, oh, where is a serial monitor? Okay, this is a serial monitor. So what I was saying is, whenever our Ethernet client, means Ethernet shield, will connect to internet, it will assign one IP address to the Ethernet shell from where we can access this web server. So I can copy this IP address, okay, Control C, and I would open a browser, okay, and let me make it big, so I will type and hit enter, and as you can see the background is powder blue color, right? You can see powder blue color, and there are 2 buttons, LED on and LED off. So when I hit LED on button, it will turn on the LED. When I hit turn off the button, it will turn off the LED, right? So I would make this to be small, this web browser, so you can see both of the screens. So here is the serial monitor on my screen. I can place it properly so that you can see it, okay, and whenever I can press this LED on button, the request has been sent to the server, and that can be seen on the serial monitor. Whenever I press LED on button, it will turn on the LED. You can see it's sending GGG. It should not have sent this. There will be some issue with the code, but LED turn on, right? Let me check if there is any issue in the code. Let's make it more readable, so I can remove this ugly spaces, and then I have the, maybe I can keep this nothing. I think the problem is not this one, but perhaps the C is equals 2, and when I upload the sketch, and I hope this time I can able to see the difference in a code. Okay, so let me open serial monitor once again, and let's hope to get it up and running. So I have this new IP address. I can copy and get into the browser, and as you can see right now, as soon as I put the new IP address and hit enter, you can see there are HTTP requests. Get HTTP request has been received by the browser, and when I press on button, you will get the button 1 on and your LED is turned on. When I press off button, you will see your client will receive button 2 off and the LED turn off. So turn on the LED, turn off the LED. So this is how you can able to make the a minimal web browser on Arduino Uno, where you can host a small little web pages, HTML web pages, and create a server and control the Arduino Uno. In the next video, perhaps we can make this code a little more abstract, where we would not only control an LED through buttons, but we can also read the data from the sensor. So I hope you will find this video educational and entertaining. We'll see us in the next video. Thank you very much. See you in the next video. Bye bye.